Hello, welcome to Chapter 10, Section 1, where we're going to organize and display data. We are going to learn about how to draw graphs or how to interpret the graphs, and how to take the data and make a picture out of it. The three main types of graphs we're going to be dealing with in this section are bar graphs, and a variation of that, which would be double bar graphs, line graphs, and of course its variation, double line graphs. Sometimes you have triple line graphs or triple bar graphs, but we won't do that in this section. And then finally we'll talk about circle graphs, and we'll finish with talking about how do you decide which one to draw. So we're going to start off just using bar graphs. Now here's what a bar graph represents. Bar graphs are used for what we call categorical data. All right, so we want categories. Here I have the different categories of the type of food that I would find on a typical sub sandwich, which is a good thing I already had lunch because this is making me hungry. So you have bread, and this one has ham, turkey, cheese, and mayonnaise. Now, of course, you can put other things on your sub sandwich. We're just trying to keep it simple, so we're not learning about sub sandwiches, we're learning about bar graphs. So usually bar graphs are used when we have what we call qualitative data, okay? So data can be two things, okay? It can either be words or it can be numbers. We say words, the technical thing is qualitative data. So they can be either, in this case, nouns or adjectives that describe things. Numbers are what we call quantitative data, which just tells me quantities. Bar graphs usually use words. So like bread, ham, turkey, cheese, mayonnaise, those are words. They describe the categories of the food items you're going to find in this sub sandwich. And as we go through, if I have data that is separates categories, if I was doing a study of students at Highland Park Senior High and I wanted to separate them by grade, it'd be freshmen, sophomore, juniors, and seniors. Of course, you can say 9, 10, 11, and 12th graders, and those do kind of mean numbers, but in this case we'd be separating them into categories that would be grouped together using it'd be more words. So there's a little bit of confusion with that sometimes. All right, let's talk about what the bar graph actually means. So this one is a horizontal bar graph. Most of the time you see a bar graph is going to look like that. This one is a horizontal bar graph. No problem, it doesn't matter. Usually the person designing the bar graph gets to choose which way they want. Along one side, I've got, again, the categories: bread, ham, turkey, cheese, mayonnaise. I'll say it again. We call these the ingredients of the sandwich. Along this side, I have a numeric scale. So there are going to be numbers, but each of the categories has a number assigned to it. And I can read what the number is. So bread, if I go down, bread is halfway between 0 and 2, so that probably means 1. So I would say bread is about 1 gram of fat in this sandwich. The ham, which is on this line, goes down 6 grams of fat. So each of these ingredients is associated with a number that represents how much fat content you're going to get from that ingredient. Okay? So I'm going to use this graph to answer these questions, and I'll try to coordinate both. I couldn't fit the questions on the same sheet as this because then it would have been real small, but that's okay. We'll go back and forth. So the first question is, which ingredient contains the most fat? Now here's the cool part about having it as a picture. Instead of me going, okay, bread is 1, ham is 6, turkey looks like it's about 3, and then figuring out which of those numbers is the biggest number, all I do, because it's a picture, I look and say, where is the biggest bar? And these, we call it a bar graph. These lines, kind of we call them bars, all right? They're rectangles, I get that. The biggest rectangle, the biggest bar, is mayonnaise, which has apparently 11 grams of fat. So to answer my question, mayonnaise. how many more grams of fat are in ham than in turkey? All right, so now we're going to have to actually read the numbers. Ham, like I said earlier, is 6. Turkey looks to be between 2 and 4. I seriously doubt if these numbers are actually exactly on the whole number, but we're just learning how to read the graph, so don't overthink it. So ham gave me 6, turkey gave me 3. It says how many more? I want to find the difference. So that'd be 3 grams of fat. How many more grams of fat are in ham than in turkey? 3. The difference is 3. How many total fat grams are in this sandwich? So now I'm going to have to figure out all of the numbers, but it's really not that hard. Bread is 1, and actually I should write them down as I go. So I got 1. Ham, like we had, is 6, and turkey, like we said, is 3. Cheese has a lot of milk fat in it. That's between 8 and 10, so we'll say 9. And mayonnaise, like we said, was 11. 9 plus 11. So now it's easy. I'm just going to add these all together. 1 plus 6 plus 3. I'm going to group those together. 4 plus 3 is 7. And 9 plus 11 is 20. So this should give me 27 grams of fat total if I did my adding. If I didn't do my adding correctly, email me and let me know. Finally, I got to do a percent problem. This is going to be fun. What percent of the total fat grams in this sandwich is from turkey? All right. First, I need to make a fraction. So turkey, like we said, was 3. The total is 27. Now 3 over 27 is going to reduce. That's the same as 1 over 9. But I'm not going to leave it as a fraction. What I'm actually going to do is I'm going to grab a calculator and I'm going to change it to a percent. So here's what I do to change it to percent. Again, this is pre-algebra stuff, maybe even elementary stuff. If you need me to explain it, I'm here for you, okay? I'm not going to assume anything that happened outside of my classroom, but most of you are probably already familiar with this. I take 3 and divide it by 27, and I get a decimal. This happens to be 0.1 repeating, excuse me, which is what you get when you have 1 divided by 9. Now, that's the decimal. To change it to a percent, I'm going to multiply by 100, which just moves the decimal point. So the decimal point started here. Now it's moved 2 places to the right. So this is 11. It's about 11%. It's 11.1 repeating percent, but we can round off to the nearest percent. So again, the main idea from reading this bar graph is that I have categorical data that has a number associated with it, and because I draw a picture, I can easily spot what I'm going to do. If I'm watching my weight, if I'm watching my fat content, and I'm like, oh man, I really want a sub sandwich, I look at this graph and I'm like, yeah, maybe I should tell I shouldn't put mayonnaise on it. Maybe I should tell my sub sandwich artist not to put mayonnaise on it, and that might be a little bit healthier. All right, we'll see you in the next video.